Okay guys, the next one is x to the third. That's a cubic function, y equals x to the third. Some cubing numbers, that's what we call that. If you put in a 0, you get a 0. If you put in a 1, 1 to the third is 3. If you put in a 2, 2 to the third is 8. It's all the way up there. It gets taller, faster than x squared, of course. Now if you put a negative in, negative 1 times negative 1 times negative 1 is actually negative. So that ends up down here. Unlike the parabola, it goes back down on the left side. So put in a negative 2, you get negative 8. And then here's what you have. Something that looks like a tall parabola until you hit the origin, but the other side doesn't go back up. It's allowed to be negative, so it flips down. I will refer to this graph for your entire time in my class as a swooshy. That's not a real math term. I made it up, but I'm sticking with it, people. I haven't been real good about my marker, have I? So let me get the marker in there, and you guys can see your swooshy. There you go. There you go. So intercepts right at the origin. So x equals 0 and also at y equals 0. The domain, I can put anything I want in for x. So it's negative infinity to positive infinity. And I just wrote a terrible infinity. Let me try and fix that up. That was just embarrassing. The range, well, I get negatives and I get positives and I get 0. So that's also negative infinity to positive infinity. Is it odd or even? Well, it's not even because it's not doesn't have the y-axis as a line of symmetry, but it is odd because any point, if you were to go across the origin, you hit another point. So I'm going to say it's odd, and I'm going to say the reason is that it's symmetric with respect to the origin. That's not the definition, though. The definition is, I'm going to go up to the top again, if f of negative x is the opposite of f of x. It's an odd function. So look, you put in a negative x to the third, what happens? Raise a negative to a third power, it actually stays negative. So look what I got. Opposites. If they're opposites, it's an odd function. Where is it increasing? Everywhere. So negative infinity to positive infinity. That graph is always going up, even though it curves and it goes up at different steepness. It's always going up. So where is it decreasing? Nowhere. That's an empty set. Where is it constant? Nowhere. That's an empty set. Where is it positive? The y values are positive over here. They're not over here. They're negative. So starting at 0 and going all the way to positive infinity, that graph gives positive y values. Absolute maximum or minimum? No, it's always increasing. So no local max or minimum either. Okay, the next graph, the square root of x. If we did x squared, we might as well do the square root of x. Here we go. I can't put a negative in. There's going to be nothing over here. There's no negatives going under a square root, so the domain is limited. I can put in a 0 and get a 0. I can put 1, and the square root of 1 is 1. The square root of 2 is a decimal. I don't like that. The square root of 3 is a decimal. I don't like that. But the square root of 4 is 2, so I can put that point right there. Now that I think about it, I can go the square root of 9 is 3, so I can put that point right there. The rest of them are all decimals along the way, and I'm not touching the calculator for this activity. So here we go. There's your graph. Let me get my marker and make it official. There you go. That's what the graph of the square root of x looks like. Intercepts. It does hit at the origin, so x equals 0 and y also equals 0. The domain is not all real numbers like up here. We don't use any negative values. So the domain is negative x up to positive x. What's the range? The range is only positive numbers. I can get 0 and I can get positive numbers, but I don't get anything negative. So this is going to go 0 up to positive infinity. You can take the square root of 0 and get 0, so 0 is actually included here. So that should not be parentheses. I should have myself a bracket. Get yourself a bracket, people. Is it odd or even? Well, it definitely doesn't reflect over the y-axis because nothing's allowed over here. So it can't go across the origin and get over here either. So this one is neither. I'll write an empty set. I don't know if that's a great answer for that, but that's what I'm writing. Increasing, the graph's going up constantly starting at 0. So I'm going to say brackety thing 0. No, that's wrong. It should be parentheses because at 0, it's technically not doing anything yet. And it goes up to positive infinity. Decreasing, it never decreases, so that's empty. Constant, it never flattens out and goes horizontal. That's never. Positive, everything we have is positive, so it's the whole domain from 0, parentheses, up to positive infinity. I'm not going to put brackets there because if I put 0 in, I get 0. And the 0 for the y value is not positive. It's just 0. It's not positive or negative. Maximums and minimums, nope, we don't have any. Well, hang on. We do have the lowest point here, don't we? So we should say y equals 0, as in the point 0, 0 is an absolute minimum. Local max and mins, that's the one we don't have any. All right, guys, next page.